Hi, my name is Felix. I work with Shopify, where I'm a production security engineer. So for those of you who don't know what a production security engineer does, we take care of securing all of Shopify's deployments. We take care of everything that runs below the application level. For those of you who don't know what Shopify is, if you've bought something online and it wasn't from like one of the big companies that you know that you bought, where you bought from, then you very likely bought from a Shopify store. Today I'm going to talk to you about how we secure our deployments in Kubernetes. But first, let's start off with a straw poll. Who has ever run curl pipe sudo bash on their laptops? OK, who has ever run that in production? Oh, yeah, a couple of people have. And who felt good about it? There's one person back there. So we all started, if we are older in this industry, with administrating VMs. VMs made it possible for us to run stuff not on the operating system itself, but they're mutable. So our day-to-day looked like SSHing into the machines, updating them, changing something. It was not great to roll them out to somewhere else. It was easy to do changes, but that also meant that changes were easy for other people. And mutability, we found out from an SRE perspective, is the enemy. Because everyone who has rogue access to your VMs also has access to your databases, and they can install their backdoor. They can live in the system and stay there. So it was really great from a security perspective when Docker came around, because mutability was no more. For SREs, obviously, we had reproducible builds. We had faster deployments. Docker containers are way more lightweight than VMs. We have all that flexibility. So I guess none of us are surprised to see this very easy containerized infrastructure where we write our code, we push it to GitHub or wherever we will host our code, build it with Docker, and then we deploy it, in our case, into Kubernetes. Well, this still allows for manual changes. In Kubernetes, right now, everyone can still manually run kubectl, create, run, and edit deployments whenever they want. But everyone else that gains access to your Kubernetes can also run, create, and edit deployments. And that means they can just switch out the Docker file and pull down a Docker file from wherever they want. And I want to introduce, or I want you to think about something. The new curl pipe sudo bash, because it's just from somewhere. You download something, you start it, it runs forever. If you don't take anything else away from this talk, then take away this idea that if you just allow people to pull in any image they want from anywhere in the world they want, it's nothing else than allowing people to run curl pipe sudo bash on your machines. We addressed the mutability part, and we felt really great about it. But that also means we don't have apt-get unattended upgrades. So that means every image you start sits in your cloud and decays there. So what do we need to do to fix this? Well, first of all, we need to make sure that we don't deploy Ubuntu 14.4 anymore. Who still does that? I know there are people, yeah, cool. There are people who still do that. It comes with I think it's more than 30 critical and high vulnerabilities out of the box. So if you want to run that in your system, feel free to do so. Some people will be happy about it, but from like any security person won't be. So the question now must be, how do we fix this? And well, super easy. We just introduce a new service, which you can see here on the left, on your right, sorry. So when you start a new container in Kubernetes, we just have it ask whether it's OK to run the new container or not. Well, which obviously begs the question, when do we want to make this decision? We could either make it at runtime, so whenever you start a new deployment, it would go to the to-be-created service and ask it whether it can run it, and the service could make the decision at runtime. The advantage is you'll always get the right answer, right? Like if it scans your image for vulnerabilities, makes sure that it doesn't run as root, and so on, then you always get the right answer. Well, the obvious downside for this is that it's slow. So what we could do is we could pre-compute something and then only enforce its existence. So what we could do here is we could pre-compute, for example, whether it's vulnerable or it runs as root, create a signature on the image, something like this. Just a PGP signature over the Docker reference, which is nothing else than in which Docker registry the image lives, and then the Docker digest to uniquely identify the image itself. So we could pre-compute these and then enforce the existence of those signatures when we roll out any changes. Kubernetes has a concept called Kubernetes admission controllers. And for those of you not super familiar with Kubernetes, let me give you like a small introduction to them. Whenever you start a new container, the pod API goes out to a lot of admission controllers and asks them whether it's OK for the deployment to be created. There are two different kinds of admission controllers. There is yes and no admission controllers, which just either allow or deny the deployment of a container. And there are muting admission controllers, which can actually change your deployment. So they can change the workload manifest and then just hand a new workload manifest back. So for those of you who have never set up their own admission controllers, you have definitely used them before. Image policy, webhook, always pull, node restrictions, pod node selectors, pod security policies, all of them are actually admission controllers under the hood. So I want to introduce to you a new admission controller called Kritis. My team and I at Shopify have been a design partner with Google for Kubernetes' new feature, which in Google's version of Kubernetes is called binary authorization. The open source version is called Kritis. And it's an admission controller that does exactly that. It only allows us to deploy signed images. So when you now apply a new workload to your Kubernetes instance, it'll go off to Kritis on your right, ask it whether it's OK, then pull the image from our registry and deploy it into production. So that also means that if anyone should gain access to your Kubernetes cluster, they can ask it to deploy something, but it won't go through. The only thing that'll go through is images that you've signed off on. So they can never deploy anything that is outside your container registry or that you haven't signed off on. So Kritis comes with Grapheas, which is a metadata server that stores not only the attestations, so the signatures that we created beforehand for our containers, but it also stores other interesting information about our builds. It can have information about vulnerabilities, about build details, so from which pipeline does the container originate. It has package information, so all packages that are installed in your container. It can hold like other things like all the libraries, the gems, the Python packages, everything you have installed. But most important, it holds our signatures for our container. So now, when we run apply, it'll ask Kritis whether it's OK to deploy. Kritis will get the attestations from Grapheas. But where does Grapheas get the attestations from? Like, who creates them in the first place? And that is where Voucher comes in. Voucher was written by my team and me at Shopify. It's open source. Go check it out. It's what in the binary authorization world is called an attester. An attester is a piece of software or a human that takes a look at an image, finds out whether it's OK or not, and then creates a signature for it. So what does Voucher do for you? Currently, we have a couple of checks enabled in Voucher. For example, we check whether the image is in our registry, and we can pull for it. And then we create one signature. Then we check whether it's in the correct deploy pipeline and create a signature. We run Claire, a vulnerability scanner by Chorus, and see whether the image is vulnerable. If not, then we sign the image again. We check whether it has been tested by going back to Circle CI and asking it whether the test coverage was high enough. You can also talk to the Docker API and find out whether the container is root or not. And with all those checks, we create one check for every. We create one signature for every check, that way around. So now, obviously, the question is, how does Kritis, our admission controller, know which attestations it should require? Because let's say you have a test deployment, a test cluster running, where everyone can go to and just run whatever they want because there's no production data in there, but you want to give people a playground to deploy whatever they want. So the cool feature is that we have policies, which are project-wide, and they have a whitelist on top. So if you feel like you can trust an image that is external, you can just put in the fully qualified URL and SHA of the Docker image, and Kritis will always allow those images to be run. This gives you the opportunity to always pull in Nginx containers or Redis or Memcache, things that are built by the community that you don't want to rebuild yourself. The enforcement mode is basically, do you want which action you want to take? There are 3 currently. There's always allow, which is don't do anything. There is deny, which is you deny all deployments. And there is enforce block and audit log, which then comes with require attestations. And then you can list all the attestations which are required in your project. So now people don't only have one cluster and one project. Therefore, we duplicate that, put the cluster admission under the label cluster admission rules, and have the exact same information there again if you want to get more specific for specific clusters. So that now, when you run apply, Kubernetes will go to Kritis Kritis will find out which policies to deploy, to require where, and then get them from Graph.as. So this sounds perfect from like a security engineer's perspective, right? Like now we can only deploy images that are signed. Well, everyone who has dealt with an incident at this point should cringe a bit, because what do we do in emergencies? What if we really need to start something right now, to fix something, to update something, to be able to inspect something? What do we do? Do we just like whitelist the image that we want to deploy? Do we turn off binary authorization entirely? We don't have to do either of those. What we have to do is put an annotation on our workload manifest. It's called the break glass annotation. And whenever Kubernetes sees the break glass annotation, what will happen is Kritis will say, nope, I don't know this image, but Kubernetes will go ahead and still deploy it into your cluster. So if everyone can just add a break glass annotation, then what is this good for, right? Like now everyone could just gain access to your cluster and then deploy all the containers they want into your production systems by just adding the break glass annotation. So what we need to do is we need to log the break glass event, which Kritis obviously does for you. We then sift through our logs, and whenever we find a break glass deployment, we notify PagerDuty, and PagerDuty will page CloudSec, which is my team and me. So when we get paged, we know something got deployed that is not up to our standards. If it's due to an ongoing incident, then our production engineering team will have an RCA, so a search for the root cause of the problem anyways, and then just one of our security engineers goes and joins that. But like we now know that we only deploy images that are signed, and if not, there's a good reason for it. Well, are we secure yet? Unfortunately, no, but we are way more secure than before because we took out an entire class of attacks. Why am I saying that we aren't secure yet? Docker images are immutable, and that means they don't auto-update as VMs could do before. So what do we need to do? We constantly need to rescan our images for whether there's a vulnerability in them, or we need to build every image that we have daily with the newest packages and redeploy them. And there's one thing we haven't even talked about, which is workload manifests. Workload manifests hold a lot of security-relevant information. For example, whether the root file system is writable or not, whether the container runs as root or not. And all those information is still out there and unprotected. So while we have done a lot with Kritis, there's still a lot to do. With that, I'm going to give you the whole infrastructure in its entirety and invite you to ask me any questions that you have.
Hi. Could you briefly explain what would happen if today there was some OpenSSL vulnerability? What would be the workflow where you'd learn about that, and how would you react to it, just as an example?
OK. So Claire scans all of our images. So what we do is whenever Claire or Google has its own vulnerability scanner dry dock, if either of those finds a vulnerability, they'll create an event which gets logged in Grapheas, and then Voucher, the attestation creator, will find it and not sign the image anymore. We also get notified for those occurrences.
So all your code stops running? So all your code just stops running because now it has a vulnerability, it doesn't get signed, it's not allowed to deploy.
OK, so all of your images which are already running will continue to run. And then you can still, Voucher has this mode, there's a client mode where you can issue just an attestation, and you can just decide on your end that you know about this vulnerability, and you can still sign it and then still deploy it. But then you know about it, like someone had to be involved with deploying vulnerable code.
Thank you. Great talk and great shirt, by the way.
Thank you.
How often does your team get paged because people use this break glass feature? I mean, are people misusing it? And people get kind of woken up in the middle of the night just because someone had an emergency fix?
Yeah. So we're using, so Binoth came into beta a week and a half ago. So we run this on all of our lower tiers where there isn't a lot of maintenance. So right now it's really OK for us. So since we don't run this on our, we have like a tiered architecture, we don't run it in our tier 1 yet, so I don't know.
Thanks.
Any more questions? Very nice presentation. Do you think some of these checks you do could be done in the build pipeline?
They can be done in the build pipeline. Voucher comes in 3 different modes. One to run as a server in your infrastructure where you can just call out. There's also a Voucher command line tool, which you can take and put into your build kite or whatever you use and attest right from there. So we do that for some deployments where we use Google Container Builder. So yes, definitely that is a great idea. There was one question over there.
What happens when a vulnerability is found afterwards, after an image is deployed? Can you like redeploy the image still because the signature still exists? Is it cached, or what do you do in those cases?
So if you find, like, to deal with what you want to do, like find the vulnerable image afterwards, you need to constantly rescan either your deployments in the cloud or all your images in your Docker registry. And Google does scan all the images in your container registry. If you don't use Google, I advise you to just use Claire and just pull down all your running images, pull down the information of all running images once a day, run Claire for all those, and then create a summary of that, and then redeploy the image.
Thank you.
Hi. Regarding this Docker signing, what you were just saying, you are maintaining any public or private keys, or you're using some HSM server to maintain it?
This is all based on PGP, so we all maintain the keys ourselves.
So you don't use any other tool to maintain it, or Kritis itself has some functionality to maintain it?
So for this to work, you upload the public key that corresponds to the private key you used for signing into Kritis, and then Kritis knows which signature it needs to check for.
Okay, fine, thanks.
Yeah.
Hi. Do you have an unsigned process as well? So assuming, continuing what the other guy just suggested, you signed something to be good, you deployed it, you have a vulnerability scan afterwards, find out it's not good anymore. So would you remove it? Do you have an unsigned process after revalidation starts?
You cannot unsign at the moment. The API currently does not allow you to delete any signatures that you created. The idea would be that you can roll forward, so you can create a new PGP key pair. Then you can sign images at the same time with, you can allow them from the new and the old key for some time, and only sign with the new key and then delete the old key. That is how you can roll forward. Otherwise, there's no way of deleting a signature afterwards.
Two questions. The first one is there any chance there's people working on de-GCPing it and maybe adding AWS features for some of the auth stuff in Kritis?
Okay, so Kritis and Graphias are both open source, so is Voucher. So if you want to run this on-prem, somewhere outside of Google, you can totally do that. The implementations are exactly the same. The only difference is that if you go with Google, they deploy it for you. If they don't, you need to run them yourself. And I ran Kritis and Graphias on like my own cluster, so it works. It's just a lot of hassle to go through.
Okay. And then the other part was for the break glass process.
Yeah.
Is there any future plans to kind of close that open loop, either two-factor it, so there's like a time issue? Because it just seems like there's people waking up, and you know, as soon as developers have access to a feature, I sense that the SRE team may exercise pager duty a lot. You know, something to just get them to tomorrow morning or something like that.
Yeah, I mean, that's a good idea. I'm definitely going to do that when I roll it out in production. Like, I don't know. Like, I'm definitely going to bring this up because we have like bi-weekly meetings with Google, and I'm definitely going to ask them that.